Okay, so potentially you've looked at some of the SQL query videos, so you know the basics of select from where. In these days of data analytics, it's often useful to be able to provide some kind of summary of the data in a table. And the way we can achieve that is there's a whole lot of aggregation functions that are conventionally defined for SQL, and Postgres is actually quite nice in allowing you to define your own aggregation functions if the provided ones aren't good enough. All right, so how do we get access to these aggregation functions? Well, they actually crop up in the select clause. So let's say we're going to use our sample table once again. So we're selecting from R, and we want to specify some kind of summary of the table. Now, a very simple summary is just to say how many tuples are there in the table. And it turns out that there's an aggregate for doing that. It's called count. And since it's a function, and there's a special notation that we could use, star, but let's do that. So we're going to count all the x values from the table R. 1, 2, 3, 4. There are 4 different x values. So the result that we're going to get for the first attribute of the output is going to be 4. So once again, we haven't got a where clause, so it's going to look at the whole table. If I added a where clause, something like that, so looking only for tuples that have an x value greater than 2, it would find these 2 tuples, count them, or count the x values, and that would be it. We get the result 2. So without the where clause, we get the result 4, because there are a total of 4 tuples in the table. With the where clause, we get 2, because there are only 2 tuples satisfying that condition. Now, a very common usage of count, if you just want to count the number of tuples, is to say count with a star, which kind of means count all of the distinct collections of values in the table. So that's one possible aggregation. A lot of the aggregations that we'll look at in this video are numeric based, but there are other aggregations that you can use that work on different types of data. And in fact, I should have shown. So if I really wanted to, I could say count all of the y values. And so TAZC. If, let's say for the sake of argument, that these happen to have the value A, and I wasn't just interested in the total number of y values, I wanted to know how many different y values there were, then I can express that in SQL by saying count just the distinct y values. So in this case, the result that I get back would be 3. We've got T, we've got A, we've got Z. They're the distinct values in the y column. Ooh, except that here I was assuming we were going to count the whole thing. Let's change the where clause where x is greater than or equal to 0. So that would include all the tuples, because every tuple has an x value greater than or equal to 0. Other aggregates, as I said, there's a lot of numeric ones. Very common one is sum. So let's get rid of the where clause and just say select the sum of all the x values from the table R. So basically what this query is going to do, run down that column, add up all of the values there. So in this case, we get the result 10. Often, when we're doing a select clause like this, we would give a name to this aggregated attribute. So we could do something like that. In PostgreSQL, if you don't give a name to it, you get the name of the function as the name of the attribute. Now there are a whole bunch of different attributes. We've seen sum and count, but you've also got average and min and max. And if you look in the Postgres manual, you'll find a whole bunch of others that are available. Now another context where aggregation is used is to partition the table up and find some summary information about each subset of tuples. And the way that you do that is you use the group by statement. So, group by. All right, so the only way we can get interesting groups here is to group by the Z column, because you can see there are two tuples that will fall into one group because they have the value 5, and there are two tuples that have the value 3. So if I do group by Z, I'm going to first of all deal with this group here, the first two tuples, and then I'm going to deal with the second group, which are those bottom two tuples. So what we could do is, well, remember when using group by, you always have to include the grouping attribute in your selection, and that kind of makes sense because we want to know, you know, what information, which subset we're summarising. So the way we identify the subsets is by the value of the Z attribute. So we need to include that. And then if we want, we can just say how big is each subset. So that would give us two tuples in our output, 5 and 2, and 3 and 2. Okay, so there's a group based on the Z value 5, and that has two tuples in it, and there's a group based on the Z value of 3 that also happens to have two tuples. We could do a different aggregation based on the group and ask for the sum of all the X values in the group. So the group containing Z value 5 has two tuples with Z values 1 and 2. The sum of those is 3, and the Z equals 3 group has two tuples with X values 3 and 4, so the sum of those two is 7. So that's the result you get from that. So group by allows you to summarise information about subsets of the table. For, you know, if you've got, for example, a table of enrolments in a course, or in fact, table of enrolments, it would cover all courses. If you want the information about just one particular course, then you could group by the course. And if you want to know how many students in the course, select course, group by course, count star, and that would give you the count of the students in all of the courses in your enrolment table. So aggregation, very useful. There'll be more videos that describe how to build your own aggregate.